Dear students, Namaste. Let us start the new chapter, chapter 10, Algorithm and Flowchart. This is a very interesting chapter. In this chapter, we are going to learn about algorithm, flowchart, symbols used in flowchart, rules for drawing flowcharts, use of conditional statements and looping while writing the algorithm or drawing a flowchart. What is algorithm? An algorithm is simply a set of steps or instructions needed to complete a task. A recipe can be an example of an algorithm. For instance, we can define an algorithm to make a cup of tea. Here in this figure, we are seeing the 8 steps to prepare a cup of tea. First, step 1, put half a cup of water in a pan. Then, step 2, put half a cup of milk in the pan. Step 3, add 1 teaspoon sugar and a pinch of dried tea leaves in the pan. Step 4, light the burner of the gas stove. Step 5, put the pan over the flame. Step 6, bring the mixture to boil. Let it boil for 2 to 3 minutes. Step 7, switch off the burner. Step 8, filter the tea in a cup using a sieve. If anyone can read or understand English, can easily go through this set of steps and can prepare a cup of tea if he doesn't know how to prepare a cup of tea. So this is an algorithm, or we can say that this is an example of an algorithm. Let us discuss in more detail about algorithm. An algorithm is a sequence of finite or limited steps to solve a particular problem within a finite time. Algorithms are used to define steps for calculations as well as processing of data. Characteristics of an algorithm. First, clear and unambiguous. Instructions in the algorithm should be clear in all respect and unambiguous. Unambiguous means it should lead to only one meaning. Well-defined inputs. If an algorithm says to take input, it should be well-defined input. Well-defined output. The algorithm must clearly define what output will be yield and it should be well-defined as finiteness. The algorithm must be finite, that is, it should not end up in an infinite, that is, never-ending loops or similar. Feasible. The algorithm must be simple, general, and practical such that it can be executed upon with the available resources. It must not contain some feature technology or anything. That is, we can do it with our pen, paper, and present technology if needed. Language independent. The algorithm design must be language independent, that is, it must be just plain instructions that can be implemented in any language and yet the output will be same as expected. Now we are going to see how to write algorithms. Let us go through some basic terms before writing an algorithm. The language used to write an algorithm should be simple and similar to day-to-day life language. Second, the variable names are used to show the values. The values stored in variable can change in the solution steps. In addition, some special symbols are used as shown below. First, assignment symbol, that is equal to, is used to assign value to the variable. The symbol equal to is used in most of the programming language as an assignment symbol. The same has been used in all algorithms and flowchart. Next, the statement C is equal to A plus B means that add the value stored in variable A and variable B and then assign or store the value in variable C. We are also going to use some mathematical operators. I am sure you are familiar with most of the operators, that is plus, minus, multiplication. In computer we write multiplication as asterisk. The symbol is used as asterisk. Then division, next is the power, that is the caret sign, and the percentage sign is used to find the remainder. Power sign. Power means a to power 3, that is a into a 3 times. Relation operators. Relation operators are also binary operators. They take two numbers as an input, but they produces not a number, but it produces a logical value as an output, that is either true or false. There are different relation operators as shown here. You are most familiar with them, that is less than equal to, greater than equal to, and not equal to. We can write in this way as shown on in this table. Writing algorithms is all about problem solving. After being given a problem to solve, programmers never begin programming straight away. They will first do the following. Think about the important part of the problem, that is abstraction. Break the problem down into smaller parts, that is decomposition. Then think the steps needed to solve each part, that is algorithmic thinking. And the last, write down the steps which in turn becomes the algorithm. How to write an algorithm to find area of rectangle. Step 1. Define your algorithm's input. Many algorithms take in data to be processed. Example, to calculate the area of rectangle, input may be rectangle length and rectangle width. Step 2. Define the variables. Algorithms variable allow you to use it for more than one place. We can define two variables for rectangle length and rectangle width as length and width or L and W. We should use meaningful variable name. Example, instead of using L and W, use length and width as variable name. Step 3. Outline the algorithm's operations. Use input value variable for computation purpose. Example, to find area of a rectangle, multiply the length and width variable and store the value in new variable, say area. An algorithm's operations can take the form of multiple steps and even branch depending on the value of the input variables or depending on the particular processing logic. Step 4. Output the result of your algorithm's operation. In case of area of rectangle, output will be the value stored in variable area. If the input variable described a rectangle with the length of 3 and width of 2, the algorithm would output the value of 6. To write an algorithm, we use step number to show the steps as shown below. Step 1. Start. All algorithm begins with start and finish or terminate with end. We use keyword input or read or get to accept inputs or values, and we use keyword print or write or display to output the results. We use if then else for conditional problem solving, and for looping statement we use go to statements or while or for. So the algorithm to find the area of a rectangle goes like this. Step 1. Start. Step 2. Input length, say L. Step 3. Input breadth, say B. Step 4. Area is equal to L into B. Step 5. Print area. Step 6. Stop. There are three types of control structures while writing algorithm. Let us see briefly about these control structures, one of which we have just followed. First is sequence. In sequence structure, statements are placed one after the other and the execution takes place starting from up to down, as we have seen in the previous example to find the area of a rectangle. Second, branching or selection. We can also say it as a conditional statements. In branch control, there is a condition, and according to a condition, a decision is either true or false is achieved. In the case of true, one of the two branches is explored. But in the case of false condition, the other alternative is taken. Generally, the if then is used to represent branch control. Let us see the following table of the selection control. The first one is a simple one: if, condition, then, and if. It means if condition is true, execute the statement between then and if. If it is not true, come out of the statement and go to the next instruction. The next one is little bit complicated. It is if, condition, then, statements or statement, then else, followed by statement or statements, and if. It means if condition is true, execute the statement between then and else. Otherwise means if condition is false, then jump to the statement after else and execute till the statements to and if, and then come out of the control. Third, loop or repetition. The loop or repetition allows a statement or statements to be executed repeatedly based on certain loop condition. Example, while loop, for loops. Let us see the table. The selection control is while, condition, do, then undo. The next one is do, dot, 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 until, condition. The first one is your entry control loop. Here, the condition will check first, and then if the condition is true, then only it will enter the loop and it will be executed. The next one is your exit control loop. In this, first it is allowed to enter the loop, but when it is going out of the loop, then that is until x greater than 10, the condition will check. If the condition is false, then it will be terminated from the loop. Now, in the loop statement or the loop, the main problem is the condition. We have to make the condition false within the loop. If we can't make the condition false inside the loop, the program will run forever. So this is an error. We have to be careful with this while we are writing a program, or we are writing an algorithm, or we are drawing a flowchart. How to write a program? A typical programming task can be divided into two phases. First is problem solving phase. In this, we produce an ordered sequence of steps that describes solution of the problem. This sequence of steps is called an algorithm. Second is implementation phase. Implement the program in some programming language. We are going to see this implementation phase in the next class, that is in class 6. Now let us discuss the algorithm to find the sum of two numbers. So here it goes like this. Step 1, start. Step 2, input first number, say A. Step 3, input second number, say B. So we have taken a variable and we are going to assign the value by accepting the values from the user in the variable A and B. Step 4 is sum is equal to A plus B. So here it will be processed. A plus B, the process is going to take place. It is being added and the value will be, or the result will be stored in sum. And the step 5, display sum, that is it is going to be displayed or print on the monitor. The last one is stop. Let us discuss the next example, that is algorithm to find the largest of two numbers. Here we have to make a decision. So it is a decision making statement we have to use. That is, we are going to use the if then else statement. That is the selection statement. So step 1, start. Step 2, input two numbers, say num1, num2. Step 3, if num1 is greater than num2, then print largest is num1, else print largest is num2, and if. Then step 4, stop. Here in this step 3, it means if num1 is greater than num2 is true, Then we are going to execute print largest is M1, that is, this will be printed, and once it will be executed, it will come out of this step, that is, it will go to the statement after the and if, that is step 4, stop. If num1 greater than num2 is false, then it will jump to the statement after else, that is print largest is num2 will be printed, and once executed or printed, it will come out of this if statement and it will jump to the statement after the and if, that is step 4, stop. I hope you have understood this. The next example, that is the algorithm to find even numbers between 1 to 50. Here it is a problem of loop, that is the repetition is there. Let us see how to write the algorithm. Step 1, start. Step 2, I is equal to 1. We have taken a variable I and assigned it to 1. Step 3, if I is greater than 50, then now here we are checking the condition. Here is the condition. If I is greater than 50, then go to step 7. So if this is true, then we will go to step 7, that is the stop. If not, then this will not be executed and our cursor or the program counter will jump to step 4. It checks here if I%2 is equal to 0, means here I am dividing the I by 2 and finding the remainder. If remainder is equal to 0, then display I, that is I am going to display it on the monitor. This is an even number. And then if this is not, if I%2 is not 0, that is not an even number, then it will come out of the if condition, and then it will go to step number 5, that is I is equal to I plus 1, and then it will jump to go to step 3. So once step 3, I am going back to step 3 and again check the condition. So this will continue till I is not greater than 50. Here the step number 5 is the very important one, where we are changing the value of I and making the condition I greater than 50 to false. If we skip this particular step, then this particular algorithm will run forever. I hope you have understood the use of goto statement, and later on we can see also how to rewrite this with the help of while or for. Dear students, I hope you have understood something. If any doubt, feel free to ask. Go through these algorithms again and again, and if possible, write in a copy and practice it. Try to understand the steps, how to think. In the next class, I'm going to explain you in detail how to perform algorithmic thinking. So till then, have a nice time. Bye. See you in next class.